for this.
After Pat abandoned us.
And we are live. On that note, we are live. Welcome to the Orphan Podcast. Hey, welcome to the Data Center Podcast for Moor Insights and Strategy. Good morning, good afternoon, good evening, good night, wherever you may be, because we have a global audience. I'm Matt Kimball. I am this week's host, joined by the lovely Will Townsend and the absolutely amazing Paul Smith-Goodson. I'm going to throw in the joke, what's the frequency, Paul, based on your other interests? That's an old song from REM. But anyway, hey, episode 22. If our episode was a person, it could legally drink. It could almost rent a car. And yeah, we're doing great. So isn't that just fantastic, huh? All right. Let's get into what we are going to talk about. All right. We have a bunch of stuff on tap. We're going to talk about Cisco, Intel, Quantinuum, AMD, Google, Axion, and Gemini. Man, we got a lot of stuff going on. And Paul, I saw some of your headlines again, and I've got headline envy. I'm not going to lie. All right. Hey, and before we get going, we need to throw this out there. What we're going to talk about, this is for entertainment purposes only. We're not going to sing. We're not going to dance. We're not going to try and act out Shakespeare. But don't take this as financial advice or investment advice. None of us are financial professionals or trading professionals, and we don't even pretend to be one on TV, and nor did we sleep at a Holiday Inn Express last night. So anyway, with that said, let's jump into our first topic. Will's going to kick things off for us. Mr. Will, Cisco launches Hypershield to address AI security. Talk to us about Hypershield.
Hypershield. So this is something that Cisco announced this week, and it's aimed at bringing the scale of sort of AI capabilities and data centers and clouds from sort of a hyperscaler perspective. And Cisco talks about it being built on three key pillars. It's AI native, no surprise there. It is cloud native, and it's hyper distributed. And so, from my perspective, the company didn't wait long after the close with Splunk, and I'll be weighing in on that in a future Forbes contribution more than likely. But what I really like about Hypershield, number one, I love the name. I'm a Star Wars nerd. Reminds me of hyperspace and Han Solo and Chewbacca. So I love that about it. But from my perspective, AI workloads are going to be moving to the network edge and into the client with the rise of AI PC and that sort of thing, and just the need to do things more cost effectively from an AI workload perspective. So when I sort of look at this at the surface, Cisco aims to sort of address that, protecting apps, data, and devices. So I will be weighing in on this topic as well with a contribution, but it's sort of, from my perspective, it's sort of a kind of a security fabric, to sort of protect, the models and the data and the apps. So, Matt, what do you think? I mean, from your perspective, is it compelling?
I think it's absolutely compelling. I'm kind of curious about with Hypershield and talking about things moving out to the edge, if this is more than just AI, if this is kind of kind of on the edge security in general, right? A security fabric for in general. I'm also curious about how this plays in with the larger Cisco security IP portfolio. And whether this eventually folds into, they've got a lot of products and services that they deliver, right? Does this eventually fold into one big, and does this become the fabric for one big security offering that they have?
Well, they're trying to sort of consolidate what they're doing from a security standpoint with Cisco Security Cloud. And to your point, certainly they have a lot of different solutions. They don't intend to be all things to all people. I've spent a lot of time with Tom Gillis that runs their security business unit. But I do think eventually this could, sort of fold in to that activity, because at the end of the day, it's the difficulty that enterprises are facing in managing, these various disparate tools.
Yeah.
And so I think this, kind of brings, kind of the whole AI security and simplifies it from my perspective. Time will tell, but to your point, I think they would be wise to keep things simple for customers.
Yeah, and I think here's we all know that AI. Everybody talks about training, and large language models, and that's captured the attention of pundits, press, enterprise folks. Everybody's talking about that, right?
Sure.
But the long tail on all of this and the long-term play is inference, and it's using that data, and that data does not necessarily reside in a core data center, right?
Right.
It's going to reside in stores that are trying to set up smart registers. It's going to reside on oil platforms. It's residing everywhere. And the question is, how do you protect that when it's quote unquote out in the wild, which Paul probably has a much better perspective on than I do. But that's the big challenge. And I think that's where this really is going to have a lot of value to enterprise organizations, obviously.
Yeah, I agree.
And one thing I was always curious about is when you keep getting better and better security, and you get more and more aggressive because you want to cut the time frames down to, you want to respond to what you think might be a threat or a problem immediately. And when they start doing that, then it seems like they're getting close to having a false alarm become a false positive. I don't know how they manage that. Something I'd like to find out more about, but it seems like that could happen. You could really impact operational efficiency and risk and everything if you get start getting a lot of false positives. So.
False positives. That's a story of my life. False positives. Anyway, let's move.
Sometimes false positives probably can be good,
Not for me. Anyway, so let's move on. Intel. So, it seems like, here's what I love about our podcast. We talk about everything from silicon to hardware. Wow, those fingers look extremely large. Silicon to hardware to software to the software stack across workloads, security, AI, quantum, obviously. All of it's like fully rounded. But to me, it all kind of comes back to silicon, and maybe I'm just kind of biased that way. But with that said, and going back to something I said a few minutes ago about all the attention being on kind of large language models and these large data sets that are being trained, and everything's done in the cloud, and it's an NVIDIA world that we all live in. While all of that focus is on and all of the spotlight is on kind of the large and kind of almost unmanageable AI implementations that force enterprises to go to cloud, Intel turns around and they build upon what they've done with the Gaudi product line in IP and release Gaudi 3, which is, they focus squarely on generative AI, but they take a slightly different approach. Whereas NVIDIA says, we're going to stand up these clusters that are going to cost tens to hundreds of millions of dollars. You're going to run them in the cloud. And you're going to reuse those for inference at some time, but it's really not going to be a power performance efficient kind of scenario because of and cost efficient because of how much these things cost and how big they are. Gaudi comes in at a different space, right? They build this ASIC that is very purpose designed and developed for training and for inference. And they focus on the meat of the market, which is the enterprise. They say, you know what, NVIDIA, you've got your big honking GPUs and clusters that you're going to deploy. But for Main Street, right, for all of those enterprises out there that want to deploy AI, but either can't afford it because it's so darn costly, or don't have the power budget and otherwise to deploy, we have this thing called Gaudi, which is a fantastic accelerator. Did some benchmarking on it where it compares very favorably to NVIDIA. From a power efficiency perspective, it's about 2.5 times better power efficient. From an inference perspective, it's about 1.5 times better. In training, they've also produced benchmarking that shows it outperforming the H100 and the H200. Take that with a grain of salt. Every vendor out there creates benchmarks that show them in a favorable light. I get it, right? Don't focus on the specific numbers, but do look at the spirit of what Intel is saying. You've got these language models. Yeah, you've got the really big ones that are going to run in the cloud, but more and more enterprises are realizing they want domain-specific and company-specific language models and foundation models. They want to run on premises. They're going to use that for to create their and make their businesses more efficient through generative AI. And this is Intel's answer to that. I really like what they're doing. They're not, they're focusing on real world application within the real world enterprises, and not kind of these theoretical approaches that a lot of other companies take, pie in the sky. And it seems to be resonating with the market. Lots of good coverage on it. I wrote about it on Forbes. You can go ahead and read it. But really, really like. And what I also like is they have this stood up through, if you think about making AI work in the enterprise, it requires silicon. We just said it, right? Silicon, hardware, software, frameworks. Everything needs to run in concert, and everything needs a little bit of optimization to tie it all together. And Intel's done a great job of building that ecosystem out so that enterprises can take these boxes, deploy them, and get up and running pretty quickly. I'm going to leave it at that. I know Paul, lives and breathes AI. You can see it. He looks like an AI creation because he's so darn. So, Paul, what are your thoughts on what they're doing?
I understand it. It's not going to go into high volume production until third quarter of 24. Yep. So that means we really won't see these in operation until sometime in 2025, probably.
Correct.
So it'll be interesting. And, they're going to have to, of course, they're going to have to do something for CUDA and provide an option for that, some alternative, and I understand they're working on that. So, it's a good system. I mean, if you save 40% of the power, that's worth a lot of money right there. So.
It is. The CUDA thing is interesting. You find that abstraction being kind of being pushed further and further up the stack, and then you have there's a lot of efforts in the market. I know the Linux Foundation has their own, I think it's called UXL subcommittee that is looking at kind of rendering CUDA as a non-essential part of the AI equation, which I think is smart. It has the usual suspects as part of it, right? As you would imagine. Although AMD is strangely not in that. But the CUDA challenge aside, which I think is going to resolve itself over time. I like the fact that they're focusing on kind of real world application of AI and real world inferencing, kind of going back to what Cisco's doing at the edge, right? Understanding that where these things are going to run, we're going to have to provide value. So
I like the value, Matt. You kind of spoke to that, sort of the balance in value for enterprises. I mean, I think Jensen, when he talked about Blackwell, I think the ASP is like in the $50,000 range, right? And so I think Gaudi, and I caught Intel Vision remotely. I know that some of the team members were there, but I was super impressed just with sort of the value that they intend to deliver with Gaudi. And I'm also continue to be impressed with what Intel is doing with confidential AI, leaning into its investment in confidential computing, really to secure these next generation AI workloads. And there was talk about that at Vision, and so I think that's really strong. And I've actually worked. I mean, it's going to be a gratuitous plug for some of the work I've done with Intel. But last year, worked on a paper that was commissioned by Intel around speaking to what it's doing with extensions in Xeon, to facilitate confidential computing and the ecosystem that it's building. It's doing the same thing with AI, and actually I'm about to kick off a new paper that's going to focus on that. But also the ecosystem investment, the partnerships that Intel forges with NVIDIA and with others. I really think it's going to provide a lot of momentum behind Gaudi as it enters production, as Paul mentioned, in calendar third quarter.
Yeah. I think the whole, I think it's called TPX, their security framework, the encryption of in enclaves encryption, along with obviously encrypting data that's sitting in physical memory is certainly a big play. And I like that it has minimal performance hit. So anyway, that could take us in a totally different direction, which I don't want to do because we have a volume of millions to talk about. You're going to have to take a guess at who came up with this one. Mr. AI and Quantum, Paul Smith-Goodson, the floor is yours. You've got the soapbox.
Quantinuum has been doing some pretty good things. They recently, just in fact, I wrote about it and just published in Forbes today, is a project they had with Microsoft using logical qubits, and they reduced the error rate 100x lower error rate with these logical qubits compared to what the underlying physical qubit error rate would be. I think we talked about that before.
Yep.
But Quantinuum has been moving along. They've set a record here a new record for quantum volume, and they've also improved their 2-qubit fidelity. It was 99.8%, and now they've moved it up to 99.9%. Qubits are very sensitive to the environment and the lethal, radiation, cosmic rays, things like that will cause it to be an error. So 99.9 is it sounds like a small improvement, but it's actually a big improvement. It's going from like, 1 error in 100 operations to 1 error in 10,000 operations, that type of thing. So, so they've basically got the record for the error rates in the quantum industry right now, and they've also improved their quantum volume. Pat and I worked with Honeywell Quantum Solutions, which is the precursor to Quantinuum, when they first launched the business. And at that time, they were kind of staking their reputation on quantum volume. Quantum volume is an IBM measurement. It's kind of a holistic measurement that takes into account a whole bunch of different things for quantum computing. And they set a goal that they were going to raise their quantum volume by an order of magnitude every year. I think they were going to do it for 5 years, so I think they've got one more year to do it. At that time, when they launched Honeywell Quantum Solutions, their big thing was it was the most powerful quantum computer in the world, and they did that on the basis of a quantum volume of 64. Over the years, they've gradually increased, not gradually, but every year it's basically 10 times higher than it was the previous year. So this year, they've got a new record for their quantum volume. It's like 1.2 million. It goes back comparing it to 64 when they launched. So they've done a good job with the technical aspects and improving the machine. So every little bit of improvement in fidelity unlocks new possibilities and challenges that they can accomplish within the quantum computing.
So let me ask you a question. First off, Will, is it just me, or does when Paul speak, it's like it's so smart, you're just like, I can't think of a good question.
My IQ points rise every time we do this podcast with Paul. And I understand about a third of what he's talking about, just enough to be dangerous.
Oh, that's very good.
That's the nice thing about being in quantum is that you can kind of make up things. And
Qubits.
5 years from now, no one's gonna question whether you were right or wrong.
Right.
Hey, Paul, because we have thousands of new listeners coming on from around the world every week, I know daily.
Yes.
I know we've asked this question before, but when do you see, as the quantum guy, and I mean that kind of industry wide, you're known as like the quantum guy. When do you see quantum having kind of broader and real world kind of application? Part one. Part two, what's the down market impact of that?
Yeah, the big thing, well, there's a couple of things holding quantum back right now. Basically, error correction is the big problem.
Yep.
We need to do the real type of computing. We need basically a fault tolerant quantum machine, and that's almost like now we've got we're happy about 99.9% fidelity. What we need is 99.999.
Yeah.
That's what the goal is. So, and every little bit, it's a struggle. But Quantinuum's got a good architecture. The good thing about that, they've got something called a QCCD architecture. It's basically instead of having one big linear zone with a bunch of qubits in it, they've got different zones that they set up. They move qubits in it and perform operations. So it cuts down the noise and makes it more efficient. And so they're in a position really to scale up, keep improving their fidelity, and scaling up more and more qubits as they improve their fidelity. So it looks like pretty good. I would say this thing with Quantinuum and Microsoft is a fairly big deal.
Mm-hmm.
I'd say it is a big deal using logical qubits. And the way it works is it takes like maybe 7 or 8 logical qubits, really physical qubits, but what they do is that you take the quantum information from a physical qubit that does the computing, and you spread that quantum information across these 7 or 8 qubits that become a logical qubit. Mm-hmm. Because you can't measure a quantum state directly because you collapse it.
Yeah.
So they use logical qubits. You can measure what's happening to the logical qubits without collapsing any states or anything like that. So as we move along, the goal, I know Quantinuum's goal is that in 2025 they're hoping to have a new processor called I forgot the name of it, Helios, and that will have 10 logical qubits in it. So they'll be able to do some really interesting things with that. So.
Yeah, you lost me at qubit. Just going to throw that out there, but that's okay.
Anyway, things are moving along and doing great.
Excellent.
Cool.
All right. So, hey, we talked about Intel, talked about Cisco. It would almost seem wrong if we didn't talk about AMD and all the good work they're doing with Pensando. Exactly. Will, you've got the floor. Hey, and I'm going to mess around with formatting. So if you go ahead and start talking, and I'm going to try and make you bigger in the focus of this conversation. Okay.
Well, thank you, Matt. I appreciate that.
That's how I roll.
Yeah. So I recently had an opportunity to spend some time with the AMD Pensando team. They've been partnered with HPE Aruba Networking for quite some time. You're making me dizzy, man. And that sort of culminated in an opportunity for me to work with the AMD team and publishing a research paper, going a little bit deeper into Pensando. And, there are a lot of DPU options out there, right? Mm-hmm. You've got NVIDIA, you've got Bluefield. Intel has its Intel processing unit. Marvell does DPUs. But, what I really like about Marvell, and this, again, is a gratuitous promotion for my research paper, that our viewers and listeners, if you're interested, you can go hit moorinsightsandstrategy.com and download it and learn more. But what I continue to be impressed about AMD is just, the sort of the evolution of that platform, a focus on providing software. Shocking. We were talking about AI platforms earlier. Platforms are defined by silicon, software, ecosystem, blueprints, you name it. And so from my perspective, some of AMD's competitors in the DPU space, they sort of allow others to sort of focus on the software and that sort of thing. They all arguably enable ecosystems, and that's really important to ensure design in a silicon and that sort of thing. But again, I continue to be impressed with just the holistic approach that AMD takes. And I know they're your former employer, and so you're pretty bullish on them as well. And for me, talk about, business outcome. And and that really, from my perspective, demonstrates the power of any solution. And in the course of writing the paper, I did get to speak with a partner at DXC Technology. So DXC Technology has deployed the Aruba CX10000 switch that contains the Pensando DPU. And they've accomplished some pretty amazing things. They've been able to consolidate their data centers from 200 down to 60. And at a very high level, and speaking with a few executives there, they've realized almost a 50% operational performance improvement deploying AMD Pensando. So very, very compelling. And I know, Matt, you're a former employee. I'd love to get your take on where you think AMD is headed with Pensando relative to the competition.
Well, I loved the fact that AMD went out when they first acquired Pensando. Just like when they acquired Xilinx, I was so happy to see them do it because to me, it showed, they were a company that for a few years after launching EPYC, they had a lot of work in front of them establishing themselves as a legitimate, not even alternative, but competitor to Intel, right?
Yeah.
To me, acquiring Pensando and Xilinx signaled that they had arrived and they had established. And I love that they're able to complement all the goodness they've done in EPYC with Pensando, with Xilinx, and sometimes all together.
Yeah.
What I'm curious about is I see a lot of work around Bluefield from NVIDIA kind of building out an all-up AI environment, right? And I see companies like Vast Storage and others really kind of, Vast Storage, Vast Data, and others really kind of glom on to leveraging Bluefield to deliver faster data to AI machines, if you will.
Yeah.
And I haven't followed Pensando as much, but I'm curious about whether there is that same level of ecosystem support for Pensando. I have to think there is. I just haven't been tracking it as much.
No, there is. And I mean, what NVIDIA is doing may be a little more front and center and visible because, again, they're leaning heavily on the developer community to put the software around what they do. Again, AMD has made an investment in that, but absolutely, AMD has an ecosystem, that has been built around that to support, the scalability and, future, capabilities that can be leveraged from it. So.
And I love that Lisa and team have taken these acquisitions, Pensando, Xilinx, and have let them run and continue to innovate and don't focus on specifically just an AMD stack, right? I mean, it's like, go be the innovation engine you were that we fell in love with and continue to grow and build your compelling value prop instead of like, how do you fit into everything we're doing, right?
Right, and then sell adjacency, right? So I think your point is spot on. They've done a great job, allowing these acquisitions to grow and innovate. I mean, because oftentimes, and you and I and Paul know this. We've worked in corporate America. Often when you combine acquisitions, you lose something.
Yep.
So,
yeah. It's not the 1 and 1 equals 2 or 3. It's the 1 and 1 equals 1.5. Right?
Usually, that sometimes happens. So
Unfortunately.
Yeah.
Staying on the silicon track because we are so silicon focused and we love silicon. Don't know if y'all heard the news, but Google announced Axion. So a little bit of a primer for our 40,000 listeners out there and viewers. First party silicon creation, design creation, manufacturing has become a trend in the cloud, if you will. It's for good reason, right? Because AWS, Azure, Google, Oracle, IBM, they all understand their cloud environments better than, any CPU vendor could possibly understand them. They understand their thermal requirements, their performance per watt requirements, their performance per dollar requirements. They understand different services and kind of, when you need to turn up frequency, turn down frequency, you need a bigger cache, L2 cache, L3 cache, so on and so forth. And so they have a much better understanding of what their requirements are. And that has led to That's what has led to this Russian ARM, right? And this kind of big ARM invasion of the cloud data center. AWS was first with Graviton. It's up in the mid-20s as far as percent of deployments within AWS goes, which is huge.
Yeah.
Azure recently announced Cobalt, their homegrown, homespun ARM CPU. Ampere is out there with merchant silicon, and Google, who has a long history in silicon development with TPUs, recently announced, just about a week ago, announced Axion, their version of ARM. It's going to be used for internal workloads, things like Spanner, which is a distributed database, which has very unique requirements. YouTube, everyone knows YouTube. Google, which has yet a different set of computational requirements. They're going to use this thing everywhere they possibly can, and they're also rolling it out into GCP for customers as well. So, going to be a really interesting play with Axion. I'm really curious to see how wide and how broad this gets deployed across their GCP instances, and what this is going to do in terms of their relationships. And I'm always curious about AMD and Intel and how this impacts these folks, these players financially.
Yeah.
If you think about AWS, nearly 25% of its environment has moved from AMD and or Intel to homegrown. That's a significant, when you're talking about millions of CPUs, that is a significant hit financially.
Yeah.
And when you take that hit financially, it means you can't invest the way you've invested in the past, right? That's money that you can't put into developing maybe an adjacent product line or going into other projects and strategy or strategic movements, right? So I'm kind of curious as to how, number one, does this continue from GCP, Oracle, or GCP, AWS, and Azure to an Oracle and an IBM, and who does their own silicon anyway, and others? Or does a merchant silicon provider like Ampere or another competitor really start to take aim at kind of down market cloud providers? That's part one. And part two, what is the long-term impact to an AMD and Intel? We know they've launched their high core count parts to compete with ARM, right? You got Bergamo from AMD, and Intel's going to have Sierra Forest here in a couple of months, 144 and 288 cores. What does this mean? And does ARM eventually create their own part that they sell as a silicon merchant? Who knows? But it's fun to pause it and fun to watch, and it's really cool to see this innovation. Who would have thought that companies would be building their own silicon in the year 2024?
It's crazy, right? I mean, Matt, from your perspective, is this sort of me too? Because AWS has made a lot of noise with Graviton. So you've got Azure with Cobalt now, Axion with Google. I mean, is this a me too, or is this like, do they clearly want to create some differentiation? And I get it. They each understand their individual architecture and environment and challenges, and they're bringing custom silicon to sort of go address this. But is this racing stripes?
Here's the thing. It's a really good question. Here's the reality of how the CSPs and any hyperscaler plays, right? Think about Meta, Salesforce, other kind of hyperscale organizations, right? NTT. These guys are driven by margin, right? So I deploy an EPYC processor, a Xeon processor, or a Graviton processor, and it costs me, I'm making these numbers up, right?
Yeah.
$1,000 for that processor. Over the next 5 years that this thing is deployed, I'm going to make some amount of money back off that.
Yeah.
If I could deploy an alternative and make 2 extra points of margin, I'm going to do it. Yeah. This has nothing to do with, there's a lot of talk out there about, like Azure built Cobalt because they wanted to be in the silicon business, or, Google, they feel kind of left out, so they have to jump in. That is what you're articulating was something a lot of people say. The reality is they're driven by money. The minute it makes sense financially for them to do it, they're going to do it. The minute it makes sense financially to not do it, they're not going to do it. When I was at AMD, we saw this, right? Cloud providers aren't fickle. They're not sentimental. They don't play favorites. Their favorites are themselves and their bottom line. So they're going to go with whatever provides them, when they plug it into their spreadsheet, whatever provides them the highest percent of margin, that's what they're going to go with.
Okay. That makes sense, and certainly using ARM gives them some flexibility, right? Because it's a high bar to do custom silicon, right?
Mm-hmm.
So ARM helps sort of, maybe, kind of reduce the friction and,
ARM has a program called CSS, Compute Subsystems. And essentially what it is you take their family of data center technologies called Neoverse. So it takes that Neoverse IP and it allows you to take it in a near ready state and then kind of turn the knobs for your specific requirements, right? So your time to development goes from 3 years down to 6 months, right? Yeah. I'm exaggerating a little bit on both ends of that, but it greatly reduces the time it takes for you to go from concept to actual deployment of silicon within your data center. That makes it very, very easy for these folks to turn product on pretty quickly. And if you wanted to take it in just kind of a vanilla state and deploy it and not turn any knobs, you could do that as well. So that's why ARM is appealing to them. Something Google did, which I thought was really interesting, is they didn't specify like the specifications of Axion. They didn't tell you how many cores. We know it runs on V2 of Neoverse, but that's it. Don't know the cores, don't know the memory, don't know the cache sizes. So they're offering this out truly as a utility to customers, right? Which I think is really interesting because to me it's like this is where silicon becomes a commodity. Yeah. You don't, as an IT shop, you don't need to know how many cores I have in Axion. You don't need to know how much. You need to know whether you can get 2, 4, 8. 32 vCPUs and how much RAM you can get to go along with that. That's all you care about. Yeah. So your instance sizes, that's all you care about. You don't care about what sits in the background. But anyway, I could talk forever about this. Sorry.
Yes, you can.
And Paul's bored because he's like, this is like so elementary and basic. so smarter things to think about.
Baby stuff.
Right. Hey, Paul, with that said, we're gonna flip back to you to close things out. And I'm going to take style points away from you for this headline because you used millions twice and one in your previous.
That was intentional. I was trying to integrate the subject. That's the only thing I could think to do.
Well done, sir. Well done.
Gave you 3 incidents.
What do you got for us with millions of tokens? I'm thinking like arcade and playing.
I know. I want to go play Donkey Kong. Donkey Kong.
A little train that comes down and picks up the toys.
Asteroids and Pac-Man. Yeah.
Well, there's a new sheriff on the block. It's called Gemini 1.5 Pro, and it's off the line of the Gemini Pro from Google. Mm-hmm. And it's a multimodal model, and it's got some really neat features in it. It's very powerful too. It's got the standard architecture. It's got an architecture called a mixture of experts architecture, and that's where it basically breaks down problems into groups, and then it assigns sub-experts to solve each group, and then they put it all together. So it's kind of neat. They have advances in training and the infrastructure. It's got one of the really nice features about this is it has a really large context window. You can cram a million tokens into the context window, and that compares like to the last leading AI model. They had the biggest context window was Claude, and they had like 200,000 tokens that they could use. So gone from 200,000 to 1 million. And in addition to that, it's got really long context performance in terms of remembering. Well, let me tell you what it does first of all. Like I said, it's multimodal. You can load in like a video of something, like a lecture by a professor, and you can say create a quiz with an answer key to it, and it'll go through and read all the information in that video and read all the audio, and it'll create a quiz for you. You can put a video in there, put a video in there, and ask the video what frame and what time did the villain pull a knife out of his pocket.
Oh wow!
It will come back and tell you the frame, the time, and I mean it's pretty neat. It's got almost a perfect retrieval performance up to 10 million tokens.
Wow.
Oh, wow.
So you can load a lot of stuff in there and ask it to do things, and it looks really neat. So it's got the long form inputs for text, video, and audio. It requires less compute than the Gemini 1.0 or required. It's got some new abilities with that in-context learning on the documents. They did some tests on it. It's called needle in the haystack test. And it's just what it sounds like. You look for a needle in a haystack.
Mm-hmm.
They ask it to perform a search they broke it up into audio, video, and text. And they ask as a benchmark, they ask it to find a certain item out of 10 million things. And it was almost perfect for audio and video. And it had just a few errors in text. So it's pretty competent. And I think people are going to get a lot of usage out of it. I'm really impressed with it.
So Paul, if I go to gemini.google.com, am I seeing this version 1.5 now, or?
Yeah, there's 3 of them. I think there's I forgot what the first one is. There's Gemini, the first one, then there's Gemini 1.0, and then Gemini Pro 1.5. So Pro 1.5 is basically a smaller model.
But
it does really, really neat things.
But is this stood up through going to Gemini.google.com, and like any consumer who goes to that Gemini?
Well, it's in a public review right now.
Yeah. Okay. Got it.
Yeah. One of the tests that they had a benchmark test on. They gave the model a grammar book on a language called Calamang language. It's only spoken by 200 people in the world. And they did some tests on. They had ask it, how do you say, where's my father? And they did a bunch of tests like that with people, and it came out perfect. So
wow,
that's incredible.
Pretty neat model. It's in the garden, the Vertex garden, and so.
I'm gonna have to learn Calamade. Is it Calamane? I gotta learn that.
Calamang, I think.
Okay.
Yeah.
I want to be unique. I want to stand out.
there you go.
That's my tagline.
Yeah.
So
just going to a bar, say, anybody here speak Calamang?
strangely enough, that's great. That's a great dinner conversation.
Yeah.
Impress your friends.
For sure.
Hey, so listen, we've come to the end of a really cool podcast. I want to thank all 600,000 people for viewing us today.
Thank you.
We greatly appreciate it. If you like what you heard and you think we're funny and good and smart and you got some value, please click that like and subscribe button. If you have complaints, send them to Patrick Moorhead, because he refuses to show up for our podcast now, so he's on the hook for taking all the complaints. And one more time, do not take anything we say as advice or advise in an advisory sense for investing or anything else. This is for entertainment purposes and just 3 guys sitting around bantering about tech. So
we don't want to sound like we're elite, so we intentionally sound stupid.
Exactly. I go out of my way to sound like an idiot. Hey, but before we go, y'all traveling over the next couple of weeks? I want to get that nailed down so people, if they're looking for you, they know where to stalk you.
Yeah, I can start. So I'll be at RSA conference early May, so second week of May. Media Tech the week before with Anshul Sag, one of our esteemed colleagues, for an analyst event there. Dell Tech World. I know, Matt, you and I will be there together with Patrick
Yes, sir.
towards the end of May. And then June, Cisco Live, HPE Discover, and Zscaler Zenith Live.
Yeah.
So hit me up if you're going to be there and if you want to talk tech.
Busy. How about you, Paul?
Yeah, I've got some things coming up in May. I'll be in a convention in Ohio, and later in the year, I've got a few trips back east to New York, and I've got a couple of pending trips right now too.
Excellent.
Nice.
I'm going to be at Oracle Database Summit next week, hanging with my buddy Steve Zavanek and all the cool folks at Oracle. I'll be at Red Hat Summit the week after that, and then Microsoft Build, Dell Tech World, Nutanix.next, and IBM Think. So, and then the June hits. So the June swoon. So, yeah, definitely hit us up if you want to get together, grab some coffee, and talk tech. We love doing that. Until then, and until our next podcast, thanks for listening in, and can't wait to see you again soon. Thanks, guys.
Thank you.
You guys.